All right, so I want to do mesh deformation, and I was originally doing 2D stuff and realized suddenly that my code could do 3D. Everything I had done for the math was all 3D supporting, so I started pulling in 3D objects, and I'm really liking the tooling for this. So I figured I'd share the video out on exactly how to do this. Okay, so I have a car here, a Lamborghini. I'm going to try to get to the code very quickly here, so let me just show you a few things about how it works. If I were to take this shape and basically apply the deformation, we can see it becoming an entirely different vehicle right here. So its bottom end is more upright. It looks like it's more dune buggy able, that it can hop up on different things. Also, I can manipulate this. This is easy to do at design time, but right now I'm going to copy the focal points so I can reproduce this exact same one. And then I'm going to generate a new shape for the car. There's a new shape. This one, not so much. Not really caring for it as much. Let's try something else. Ooh, I kind of like that one. I like what it did with the lights on the front. Okay, yeah, I like that one. It feels a little more Batmobile-ish. Now, keep in mind, I'm only deforming the body mesh. This one still has separated elements for the doors, for the windshields, for the hood, and for the rear hood, for the engine cap. All right, but I'm just deforming from one point to another. Now, this is also very editable. So let's say I wanted to drop down this front point even more. Let me go ahead and show the focal points. The focal points are all the different points on this where it is attaching the mesh to. Now that location needs to be up a little bit more, and let's drag it over to this side. Let's widen this up a little bit. There, so that's the new front of my car. And then over here, let's also grab another one of these, drag it over this way. But you can see I can do these custom real-time alterations to this. So I get all sorts of different effects and styles. Now let's drag this over and then up. There. So there's my new shape to the car. Now this is all manipulatable. You can tweak and edit this to whatever you want to do and get very new shapes and designs for it. Now let's drop that one down, whatever. Right there. Okay, anyway, so we can do all of this design structure to this and be able to manipulate these cars in real time. This can be done in Editor or IDE, but let's dive into the code. What's it actually take? So to begin with, I'm going to start with the key thing here. If you want to be able to edit a mesh, if you want to be able to edit the mesh and deform it and alter it, it's just a whole bunch of vector 3 positions. Just think about world space positions. You've got a point over here, a point over here, a point over here. And if you move one up and down a little bit, then on the triangle, that triangle will deform up and down a little bit. So it's really not too complicated of a concept if you're already moving objects around. Now, to actually get those, the initial check on this, which it triggers at 2 different points. If we change a value in it, on the onValidate function, or during the start, it will check this stuff as well. All right, so that means that if we construct a new object, attach this to it, it generates an initial copy of the mesh. So we get this mesh, what it is. Oh, target vertices, I got rid of that. It's not there anymore. But we do our initial check. And that initial check, we get a copy of the mesh from the mesh filter. The mesh filter is what stores all of the triangles. It stores a list of all the vertices, then it stores a list of all the triangles, and then it stores a list of all the UVs, the UV maps, etc., everything else that goes to generally shaping and coloring a particular model. Okay, but we're grabbing the mesh. Now, when we're grabbing the mesh and we're setting values inside it again, it's actually instantiating a new copy that gets stored to the scene. Now, if I were to take that and save it out to a prefab, then it's saved in that prefab instead of the scene. But this can, depending on what you're doing here, you can get a lot of excess memory in your scene load. Okay, also, if you're making the meshes dynamic, you're specifically changing them. You can't use static, or you shouldn't use static because it'll mess things up. All right. Now, on this one, we're getting the mesh, so we have a reference to our own mesh object, our own mesh filter. we're saying the original vertices. Get a copy of the original vertices. This is only if it has never been set before on the initial construction or creation of this object. So on its initial setting, it grabs a copy of it. Now, if we actually change out the mesh with another mesh, that kind of destroys this code. But this code is also designed to manipulate and affect things. So its original vertices, it's not going to know them anymore. It won't make sense. It'll have a different stored set of original meshes or vertices. Okay, so the initial check happens. Then this is where the magic happens. We grabbed a copy of the original vertices. Now we're going to set the percent to the target, those focal points. How much should we pull towards them? Okay, so we're also setting and storing the values, so we can come back to this later. But we're using percent for it. Now, we're going to get a list of vertices. We're creating a new list of vertices that are just a bunch of vector 3s that match the original vertices. It's the same length. Because at the end of this, we're just going to push those vertices back in. We're just going to say mesh vertices equals vertices, and that puts them all back in. And ultimately, we're going through every one of the original vertices, and we're generating a new modification to vertice. And we're just going to modify it by doing this lerp statement over here, vector3.lerp, where we pull in the original vertice and then the new point that we're trying to get it towards, and how much of a percent it's supposed to lerp between one to the other. So it sets each of the vertices like that, and that's where we get our vertices. Now, the code to actually figure out which one we're doing and how this particular mesh deformation works, there's a couple extra things. This one we can kind of ignore for a moment. We'll come back to it. All right, so for every single vertice on the original object, if I go back into here and you can see all these triangles that are into here, every one of these, here is a vertice, here is a vertice, here is a vertice over here, and these three put together make this triangle right there. But this is produced of a lot of different vertices. Okay, so we want to take every one of those vertices and compare it against every focal point. So every focal point, when I zoom out, let's select the body and enable that. So that's these points that all have this design editing tool on it. Let's go over to the hand tool so I don't see that center one. So all of these are being compared to the focal points. And so these triangles right here are closest to this focal point. So as I start to stretch this out, you see it's pulling them all over to that point. This was the closest one to them. All right. Now that's not where I want to take it, but whatever. I'm just showing it for the design. Now let's continue on. So all we want to do is find out which one is closest. That's all this piece of code is really doing. We're just finding out which variable is closest to it. So we're taking a look at every focal point. So keep in mind, the more complicated your mesh is, the more work it takes. Now, this is also a great point to do a little bit of extra work. On this point where we are getting the mesh, we could also map out the comparison, or anytime that we change the values. Anytime we do, on validates. We're doing something that changes the values of each one of the focal points, we could generate a map. So it basically says for each vertice, here's another array with same size as the vertices array, except it's an array of integers, and that when you pass in the same one, it will give you back an integer, which is the index of what it's mapping to. So basically, you can produce a map to store it and not have to do this math every time. And then it'll operate faster in real time. Okay, but I'm not doing that here. In this one, I am specifically taking a look at the point that I'm making this deformation. And I'm doing the alterations then because I'm designing this for IDE. And I don't need to store and redo those maps every single time. If I wanted to focus on this being at runtime, I would be producing the maps. Okay, focal point. So basically on this one, we're saying the distance is max distance. We're going through every focal point, and then we're getting the distance between that focal point and our original vertice. Now keep in mind, this is all local space. So position of 0, 0, 0 will match the transform position. All right, so then we're just taking a look at the original ones. We're not doing any transformations on these. But then we are getting we're saying if the distance is less than distance, then we're going to set the focal point to what we currently have and the distance. Now, one other thing on this is that I have mirroring enabled. So mirroring is pretty straightforward. I just put in a snap axis, which gives us X, Y, Z, all, and none as a series of flags. So this is basically saying, okay, well, the position equals mirror the point, mirror the focal point. So I created this one function down here, mirror point, which basically says if the mirror axis has the flag of X, snap axis X, then we're going to say X equals 0 minus point X. Now, this does not deal with, this deals with the idea of a mesh being designed around the center point. But if you have, say, you're putting the corner, if you're saying that that is the corner, then this is not going to work well because you're going to be stretching in the opposite side really, really far away, and that gets a little weird. So there's a little bit to do with the model shape. So anyway, with this one, we're just taking it against 0. So if it was positive, we're switching it to negative. If it was negative, we're going to positive. And we do that for each of the X, Y, and Z. Now this accounts for all as well because it will swap each one of these points, and all is basically just the combination of X, Y, and Z, which is 1, 2, and 4. So we end up with 7. Okay, and we return the point. So that returns the point. Where was that? That was up here. Okay. So that mirrors the point, and we get the copy of it, and then we just do the exact same function again. Check the distance from our original vertice to this new position, and then depending on how it changed, where it's moving to, we will end. So depending on where it's changed, if it's distance, it will set its new focal point to this current position that we're working on now, that mirror position. Okay, and then finally we go back to the lerp, which I already mentioned on here. So that effectively does our mirroring. It shows the mirroring. Our initial check, we're gathering the mesh. On the start, we're doing our initial check, and we're doing a set to percentage, just to guarantee it's going to be set to wherever we have it established. Technically, this one doesn't need to be called, though. I'm just going to remove it. It doesn't need to be called, because on the start, it's already been done. And if it hasn't been done yet, if nothing has been set up and this is new, then the target positions are going to match the original position. So it doesn't matter. There's no reason to execute this on start. Okay. Now there's another function here, set random locals, random focals. So inside of here, I'm just doing a small hack that if we click set random locals, you can see it's generating a new shape for this one. Which I tried to write it to make sure it was still going to be somewhat pleasing in its appearance. It's just generating, it's repositioning these, but as long as it has mirror points on, which you can see if I turn mirror points on, this is going to get, or off, not show mirror, but let's see, oh yeah, mirror, none. So now it's much more random in its deformation. So if I go to this, you can see they're just kind of all over the place. It's kind of warped over to this side. But as soon as I turn on the x-axis for this one, because it's coming forward along the blue, the x-axis, so everything is swapped from side to side. All right. Actually, that's not a bad shape to it. I like that one. That's kind of cool. The random ones really do kind of work fairly well for this. It's not perfect. It needs to have some other rules inside of here to help form and shape to different types of deformations. But in general, it keeps it within the range of whatever that existing mesh can be. Okay, so as we set this, the first thing that I'm doing is I'm trying to find out what is the maximum and the minimum x, y, and z that the vertices currently have. So even if it's just a sphere, it's not going to be filling in the spherical shape of where it was. It's going to be filling in the rectangle from the farthest end points. So think of a box wrapped around it, shrunken down to fit exactly to the car shape or the ball shape or the tree or whatever. So that's effectively just giving us our minimum and maximum points. And then I'm generating a new list of focal points, just a new vector 3. I could also reuse the existing one if the size matches, but this could also be changed because the size didn't. and then we end up with garbage collection. So that's something else to consider. If you're doing this for runtime, for real-time operations, then you probably want to reuse the exact same focal point list, or check to see if you can. All right. Inside of this, we now go through every single one of these points, so every one of those points, and we generate a random x, y, and z within the minimum and maximum ranges, and then set the focal point. So that's how we generate our random list of focal points. And if we have mirroring on, the shape of our vehicle ends up looking really nice. All right, was there anything else in this one? Oh, yeah. So, well, onValidate just does the changes, checks for the changes. But now we have an editor. This one is pretty much not needed. I've actually moved most of this code down. So we're showing focal points and mirror focal points over here, but they're not really necessary anymore. Yeah, the mirror focal points maybe. But I could move them all down to here, because in order to get the handles to working, I could never get the handles to work if I was doing it outside of an editor script. And I'm not sure if I was just doing something wrong or that's the way that it has to work. But when I was using handles, I was able to get the views to show up, but the actual editing never worked. Okay, so I moved this stuff down into the editor, and on the scene GUI, I end up grabbing the deformer. So I have the deformer, this regional deformer script up here. And if we're not showing the focal points, there's nothing for this to do. It doesn't have anything. This is just to display stuff and make it editable. So anyway, we return and exit. But if we're still going through, then we go through every single focal point. We get the world position for each one, which is basically find its local position and then use the transform of the deformer to do transform point. This will take its local position and run it through the matrix for position, rotation, and scale to give it its new real-world position. And then also we need to be able to work with the size. We need to work with the handle utility or handles. So to get the sizes and dimensions, because it repositions it. It's not just a stable locked size that it always does. But we want to get the size that's appropriate for that world position. Anyway, then we're doing another thing to check to see if something has changed. If something has changed, basically this allows us to say, okay, we're just modifying these variables, but this editor isn't going to trigger the onValidate when we change these values. It has no idea whether or not we've really done that. So we're calling this begin change check. If a user has influenced anything that we're running through handles, for instance, this will return true when we call the end change check. And so if we end up making a change, if we were using this tool to drag something and position something around, then it's going to call the onValidate command. So everything redraws for where it is. Okay, so inside of here, one other thing we're also using is we're using inverse transform point. That is where we are taking the world position that we have, as you can see over here. We're taking the world position and we are converting that back into a local space position so we can apply it to the vertice of where that vertice is supposed to be now. Okay, and of course I'm matching the rotation to the actual object's rotation, not to the world rotation. I felt like that would be more appropriate, especially since mirroring is one of the items that we're taking advantage of. But of course, you can switch this to use just quaternion identity to match the world rotation in general. But anyway, so let's see, that's the key stuff there. That is the deforming script. Yeah, 189 lines of code. And hopefully not too complicated. I want to show you another thing. Like this is it working on a two-dimensional leaf. The original reason why I created it was so that I could have this leaf over here. And let me switch to selection. I select the item and I can deform this by basically having, let's see, show focal points. Look at all those. There are 1,000 focal points in there. So as it's deforming, it's a lot slower when I'm actually showing all of these handles and gizmos. But I'm going to get rid of the show on this, and now you can see it's able to do its deformation pretty lightly when it doesn't have to show all this stuff, all of its work. Okay, so I can expand this one out, and since there are 1,000 points, these things have so many different spots to pick from that the deformation is pretty minimal. So I can end up just doing random, and I get all these different leaf variations that in this case all still kind of look like a maple leaf. Now, another thing is that because of that, I can get something fairly similar if I were to reduce the focal point count on this to, say, 10. Because when I do this, look at that, that's cubism. So I'm running cubism here, but if I reduce the deformation strength, then I can still use this one and get similar shape deformations to it. It has a little bit less ability to kind of deform, but as what you see in the other one, so it really depends on what you need. In this case, you can get away with a much smaller set of numbers and less computational expense. All right, so another one is I have one other project, and I figured I wanted to show this one too. So I'm using an asset in this one, the hand-painted environment. Let me load up the PDF. And then let's go over to the asset stores. No, that one. Well, anyway, hand-painted environment volume 1 from Unity Asset Store is what I downloaded. So there's all sorts of different things. Like I can click this tree over here, and now I've got focal points on here. I can deform the tree into different shapes. So if I put kind of a mild one on here, I would say 200 points. I get all sorts of different shapes for this. I can do the same thing on rocks. Like let's go over to these rocks. On this one and this one, these were originally the same. In fact, let me take this one, and I'm just going to take level of detail 1. Which one do I want? Yeah, whatever, I'll take this one. Oh, LOD2, Control D. And I'm going to take this object, let's reposition it. Where's my repositioning? Over there. So now I've got a copy of that object, and I'm going to duplicate it again. Control D. So I duplicated it over to here, and I've got two side-by-side objects that look the same. Now with this one, I'm going to select one of them, and I'm going to add my component, which is regional deformer. And now I add the points, and then I tell it to deform. Now let's go up. Let's go say to 40 points on this. Randomly generate, and there. I'm getting a differing shape from this. If you looked at it, they look pretty similar, but when you're right up against it, that's definitely a different step. That also has a different shape to it. Some of the things are at different heights. Of course, you can show the focal points. Now this one I don't actually have. This is a separate project. I have an older copy of the script before I had the editing for each individual point, but I could do that over here. So let's say 31 relates pretty closely to this corner over here. So I'm going to go over to element 31. So scroll over to here, element 31, and let's change the Y value. So you can see I'm manipulating and tweaking that particular one just by hand, or by editing the settings for it. And there's also no mirroring in this one either. But we effectively get the same thing. Now, what's also interesting about this that you should know is that these deformations are happening and they're being stored. So it's now a part of the scene. If I were to take this object and like right now, actually, if I take this and I remove this, if I go back to here, it has a copy of what the original positions were when it was created. So it can put it back. But if this is deformed, like to this, and then I get rid of the script, that's still there. That's the shape of this object now. If you're using a mesh collider, a mesh collider will still work. It'll deal with the updates that are on this because it uses the mesh information to determine that. If you are using colliders like spheres and rectangles because a rectangle generally matches this, or a cuboid generally matches this shape well enough, then you're going to run into some potential errors depending on the deformations that are happening where it just doesn't feel right anymore. Okay, anyway, so I hope you found this useful. I have some other directions I'm planning on using this for, but again, if you guys have anything you want to talk about, if you have your own mesh deformations that are interesting that you know of their videos for, please share the link inside of a comment. If you have your own architecture and pattern of how you approach this, because there's lots of different ways to do deformations, I'd love to go ahead and see how you did that and potentially share it out on my channel as well if you're interested. But please share about this stuff, talk about this, and I hope you find this useful. Thanks.